you look at this chapter, okay, the main part, okay, the main essence of the reaction involving alkane is this free radical substitution. And you need to know in detail about this. Okay, maybe it can be confusing in the beginning. Okay, but I want you to listen to me carefully. Okay, for free radical substitution, we have 3 steps. Okay, what are the steps? Step number 1, initiation. Step number 2, propagation. Step number 3, termination. So there are total 3 steps: initiation, propagation, termination. Initiation is you start the reaction. Propagation is like when you have a plant, okay, you propagate them so that you get more plant. You propagate them so that you get more plant. That is propagation. Termination, when they become like tree, cannot control, cut them. Okay, so that is termination. So let's actually utilize whatever that I mentioned over here in terms of equation, and let's go and talk about the simplest alkane, methane. Okay, methane. So this methane, let's write down equation for CH4 plus Cl2, for example. There is going to be substitution reaction. So I'm going to substitute one of the H. So you have CH3, Cl plus ACl. So this is one of the reaction, substitution. Now, this substitution can happen, okay, until all the hydrogen that you have, all the 4 hydrogen that is bonded to carbon, completely replaced by Cl. So it's going to be step by step. Okay, now, okay, you have CH3Cl. What's going to happen next? Or maybe CH3Cl plus with Cl2, maybe they are going to become CH2Cl2 plus HCl. It means another Cl goes in. Okay, another Cl goes in. So what will happen next? Or maybe CH2Cl2 plus Cl2 will happen. Okay, another H is going to be replaced. So you have CH, one of the H is replaced. So you have Cl3, that H will join with another Cl to give you Cl, ACl. What will happen next? CHCl3 plus Cl2, this H is going to be replaced. So they are going to get CCl4, and that H is going to come out as ACl until complete. All the hydrogen is replaced. So there are, it will continue to happen. Okay, it will continue to happen. So that's why I'm selecting CH4, because it's much more easier to see. Okay, much more easier to see. So please take note, when I write down, I'm only going to write down for the first reaction. But if you want to continue, you can continue with all this. This is important. Okay, if you want to continue, you can continue. But I'm just replacing, or I'm just substituting one. And I'm going to write the mechanism of the reaction. The mechanism of the reaction, it can happen with Cl2, it can happen with Br2. Please take note. Homolytic fission will happen first. So the initiation step is Cl2 with the presence of UV light or sunlight, you are going to have homolytic fission to give you 2Cl dot. This is initiation. You have free radical first. Without free radicals, okay, the methane is unreactive. They are not going to react. Okay, you get the free radicals first. So I'll write down homolytic fission will happen. So after that, okay, once you have this homolytic fission, okay, what's going to happen? Propagation will happen. So let's see how the propagation happens. CH4, okay. I always like to refer like this. Okay, propagation is something like this. Imagine, okay, you have a darker heart. Okay, when someone loves you, okay, then the heart, okay, will change into like this, and then the another one change into something like this. Okay, we don't know. Okay, so it will be something like how to say, when just imagine, Okay, when we say propagation, they are going to be, propagation is going to be, you are going to react, okay, you are going to react with something that is neutral. I think better to use this term, something that is neutral. When you react with something that is going to be a free radical, you are going to get free radical. Okay, the moment you are forming free radical, you are going to have the reaction to continue. That is propagation. Okay, so neutral plus free radical. Okay, I'll tell you why I say neutral plus free radical afterwards. Yeah, so you see the neutral over here is CH4. Okay, CH4. What is the free radical over here? It will react with the Cl dot. Okay, I just use Cl dot. Okay, so that is going to be free radical. What will happen? Okay, what will happen? Now, when that is going to, let's say if you have CH4, when I react with the Cl dot, what happens is there is another homolytic fission will happen between carbon and hydrogen. So what will happen is going to be, you are going to get C dot CH3, and you will have H dot, and you have Cl dot. H dot and Cl dot, they will join together to give you HCl. And you are going to get a free radical of CH3. Okay, I hope you understand this. So it means now what is going to happen? I just take it as you are removing the hydrogen. Okay, just take it as you are removing the hydrogen. So you have CH3, and this is going to become free radical, and you are going to get a neutral molecule of HCl. Okay, you can see propagation is neutral plus free radical to give you free radical and neutral. Okay, so let's go for the next step. Yeah, the next step is still propagation. You see, free radical of CH3, what will happen now? Do remember just now I say neutral plus free radical. And this CH3 dot is a free radical. You need to react with neutral. What is neutral over here? You react, instead of Cl dot, you react with Cl2. I hope you understand. Free radical with neutral. Okay, free radical with neutral. What will happen now? There is another homolytic fission will happen for Cl2, where the Cl, free radical, okay, I'll just put over here, yeah, Cl2, and then I have CH3. What will happen? Homolytic fission will happen. You are going to get Cl dot, Cl dot. What will happen? This Cl dot and CH3 dot, they will join together to give you CH3Cl. And what is remaining? Cl dot. So it means if I write it over here is CH3 Cl plus Cl dot. You can see again, free radical plus neutral gives you neutral and free radical. This is one step. Okay, this is one step. You can do this continuously until all these are complete. Okay, let's say I want to continue until here only. I don't want to do everything. Okay, so that we can learn. Yeah, let's actually do another one more step. Yeah, so let's say, okay, let's say now I want to continue. So I will take this CH3Cl. Okay, so now I will ask question to Justin. Justin, what do I add? Free radical of Cl or Cl2? Remember.
Because of Cl.
Because of Cl. Yes. Okay. CH3Cl is neutral. Okay. you react with the Cl free radical from the initiation, okay, from the initiation, and you are going to get, okay, the H, okay, the bond, okay, will break for CH3Cl. I'll draw CH3Cl. So the bond over here will break. So you will have C dot ClH, and then the H will be dot, and it is reacting with free radical Cl. These two will join to give you HCl, leaving behind CH2Cl free radical. Can see? So what's next? Okay, this one, you take this one, CH2Cl plus what, Jordan?
You plus Cl2.
Yes, free radical with neutral. Okay, and you are going to get the Cl will go in. You get CH2Cl2. Okay, earlier there was one Cl, now the another Cl will go in. The remaining one more Cl, okay, will come out to give you another free radical of Cl. So you can see free radical with neutral to give you neutral and free radical, like what I mentioned to you just now. Okay, I hope you can understand this. Okay, still you see the product of the propagation must have, one of it must have free radical. You can see this is free radical, this is free radical, this is free radical, this is free radical. That is the meaning of propagation. Free radicals will be keep on forming. Now, what is termination? Termination is you want to control. How do you control? You control by free radical plus with free radical. I'll give you one example. Okay, if you want to end the reaction, how do you end the reaction? Maybe if I have CH3 dot, I can end the reaction by joining with Cl dot, and I will get CH3Cl. This is termination. Can I use some other things? Of course, there's so many. Cl dot plus Cl dot, you are going to get Cl2. This is also a termination. You have CH2Cl plus maybe another Cl free radical. You will have CH2Cl2. This is also a termination. Can it be like this, more extreme? How about free radical CH2Cl plus free radical CH2Cl? Can it happen? The answer is yes. Okay, the answer is yes. You can get, case if you want to rewrite everything also can, or you want to write C2H4Cl2 also can. Basically, the idea is the free radical will join with free radical to give you neutral molecule. You want to end the reaction. Okay, you can go through this again. Okay, tomorrow also I will talk about this again.